Alright, let's see, we're going to talk about addition, subtraction, section 2.1 still, addition, subtraction, multiplication, and division properties of equality. And we're going to talk about multiplication and division properties of equality in this video. So let's go to the slides that talk about multiplication and division. We've talked about addition, subtraction already. Essentially, if you've got something added to or subtracted from the variable, you've got to move that over by doing the opposite function. So we have the same idea here for multiplication and division properties of equality as well. When we added, this is a kind of a summary, when we added the same amount to both sides of the equation, the resulting equation was equivalent to that original equation. It's the same idea if we subtracted. So that's pretty much what we did in our previous slides or previous video. If we multiply or divide both sides, in other words, if we multiply or divide both sides of the equation, using the properties of equality, both sides have to be equal, by the same amount, not 0 though, by the way, we can't multiply or divide both sides by 0 because then we get a problem. Then we get equivalent equations, and we can get to step 2 in equations. So in other words, again, we're going to start with this: a equals b. We've got we've got expressions a and expressions b. B could be a number, a could be a variable and a number. If we multiply both sides of the equation by that same c, we're keeping them equal by multiplying by the same amount on each side, again, not equal to 0. But we keep them the same, and we modify the equation, and we can step through things to get to equivalent equations to get to a solution. Again, ultimately, our goal is to get a solution for the equation. Same idea holds true that if we've got a equals b, we can divide by some c number. Again, c is not equal to 0. If we divide both sides by c, we're treating both sides equally. We're treating a and b equally because there's an equal sign between them. And we get to another equation that is equivalent. And ultimately our goal is to get ultimately our goal is to get the variable by itself on one side. So sometimes if we start with a silly example, well, I know we got 10 equals 10. We got 10 equals 10. If we multiply each side by 3, 3 times 10 equals 10 times 3. We're starting with the same amount, 10 on each side. We're multiplying by 3 on each side. 3 times 10 on the left side is 30, equals 10 times 3 on the right side equals 30, and sure enough, we still get to the same spot. So let's try to go to the next spot and apply this multiplication and division property of equality to a couple different examples. Again, if we've got an equation where there's a coefficient in front of the variable, again, the coefficient is the number that's multiplied by the variable, then we can use multiplication and division properties of equality to get to our solution. So if we're starting with something like 5x equals 5, we've got 5 times x equals 5, and we've got a multiplication there. In order to get rid of the multiplication, we have to divide. So again, we're starting with 5x equals 15. We want to know what x is equal to, not 5x. So we've got to take care of the 5. How do we do that? If our original equation includes a 5 times x, we've got to divide by 5 to get to that x just by itself. Excuse me. So dividing by a number is the same thing essentially as multiplying by its reciprocal. We saw that in a couple of chapters ago. I think it was chapter 1.7. If we've got if we start with 5x equals 15, we've got 5x equals 15, we've got the equals between them, and we're treating essentially the same. We're multiplying by 1/5. Then 1/5 times 5 does give us 1, and 1/5 times 15 does equal to 15, so that 1x equals 3 or x equals 3, and we've got a solution. So essentially, if we're starting with multiplication, 5 times x, we can multiply by the reciprocal to get 1, or we could simply start with the same 5x equals 15, same thing, and instead of multiplying by the reciprocal, we could simply divide by 5. So we're starting with 5x equals 15, divide each side by 5 because it's 5 times x equals 15. If we want to get rid of the 5 times, we divide by 5. We do the opposite function, so 5x divided by 5 gives us 1x. We've got to do the same thing to both sides because they're equal. 15, what we started with, divided by 5 gives us 3, and our solution is x equals 3, and we've got the same solution, whether we do multiplying by the reciprocal or dividing by that number. So there's the idea of multiplying by a reciprocal or dividing by a number to get, or to use the multiplication and division properties of equality to get to a solution. So let's try a solution here. Let's try some examples. If I've got 12x equals 60, well, that 12x means that they're standing right next to one another. They're multiplied by one another. There's nothing between them, so we have to understand that there's multiplication between them. I've got 12 times x equals 60. To do the opposite of, to get rid of the 12, we have to do the opposite of the function. The opposite is dividing by, so we divide by 12 on the left side, and because we're using properties of equality, because these are equal, we've got to treat them equally by dividing each side by 12. 12 divided by 12 is 1. What do we have left on the left side? X equals 60 divided by 12 is, if you need a calculator, you can do it, but x equals 5. And now we can double check our work by taking x equals 5 back into our original equation. 12 times 5 is 60, and 60 does equal to 60, so there's our answer. Now these properties hold true whether the variable's on the right side or the left side. What's the coefficient in front of the w? Coefficient is the number that's in front of the w. We treat that as negative 8. Again, we've got to, if we're trying to solve these equations, then I want w, or the variable, all by itself on one side and the number on the other side. Same thing over here. X as the variable on the one side, number on the other. So if I've got negative 8 times w, I've got to use the division property of equality to divide by negative 8 on the right side. And if we're using the property of equality, we've got to treat both sides equally by dividing by negative 8. Negative 8 divided by negative 8 in my original equation on the right gives me just 1w, or w, on the right side. And on the left side, 48 divided by 8 is a positive, divided by negative is a negative. 48 divided by 8 is 6, and there's our answer. Negative 6 equals w, or w equals negative 6. If we're using the property of equality as well for this, we've got negative x equals 8. And if I've got negative x equals 8, we've got to understand that if there's no number written here, we've got to understand that it's a negative 1. X equals 8. And if we're trying to get x just by itself, not negative x, but x just by itself to solve the equation, then I've got to say, well, I've got negative 1 times x. I've got to divide by my coefficient. So divide by negative 1 on the left side. Because we're using properties of equality, then we also have to divide by negative 1 on the right side. And the next level down is negative 1x divided by negative 1. Negative 1's cancel out to just 1. And on the left side, we've got just x equals 8 divided by negative 1. Positive divided by negative is a negative. 8 divided by 1 is 8. And there's our answer. X equals negative 8. If we plug this into the original equation, negative 1 times negative 8 is 8. And 8 is equal to 8. Sure enough, it checks out, and we've double checked our work. Now, this one gives us a little bit of a conundrum, I guess. We've got two different options for this one. If I've got negative 2/9 times q equals 1/3, well, I want just q by itself, because again, I'm solving. Solving means putting q, or the variable, on one side and the number on the other side. So if I've got negative 2/9 times q, I can do one of two things. I can divide by, because I've got multiplication, I can divide by negative 2/9. And if I'm dividing by negative 2/9 on the left, I divide by negative 2/9 on the right. Negative 2/9 divided by negative 2/9 gives me just 1 on the left, so I can cancel those out. On the left side, I'd have q is equal to 1/3 divided by negative 2/9, and here's where we go back to variable land, or sorry, fraction land. 1/3 divided by 2/9 is 1/3 times, or sorry, negative 2/9, negative 9/2. If we're dividing by a fraction, we multiply by the reciprocal. And now we've got q is equal to 1/3 times negative 9 over 2 is 1 times negative 9. I'm going to go the long way. Over 3 times 2. Q is equal to 1 times negative 3 times 3 over 3 times 2. 3 divided by 3 goes away, because 3 divided by 3 is 1. And we have what's left. Q equals what's left in the top, negative 3 over 2 and I'd be happy with that answer. Q equals -3/2. The other possibility would be, instead of dividing by the fraction, dividing by the coefficient, we could multiply by the reciprocal. So the other option is to multiply by the reciprocal. Let's see if I can change pens here. Go to red. And see, the other option would be to start with -2/9 Q equals 1/3 and just multiply by -9/2. If we multiply by -9/2, this multiplied by -9/2 cancels out with the -2/2. This cancels with that cancels with that. Negative times a negative is a positive. And if we're doing the properties of equality, we've got to do the same thing on the left side and the right side. So we could multiply by negative, we would have to multiply by -9/2 over here because we're multiplying by -9/2 over here. Again, when we multiply by -9/2 over here, we get this coefficient to 1, and now we've got to do the same thing over here. And now 1/3 times -9/2 is essentially where we got to right there. So your choice, if you see a fraction in front of, or a fractional coefficient, to either divide by a fraction or multiply by its reciprocal. Either way, you get to the same spot. Q equals -3/2, because this fraction is the same as that fraction there, or this fractional multiplication. And essentially that's what this tip says down here. Okay, there's properties of equality for multiplication and division.